How's it going, everyone? And in this video we're going to be walking through how you can build and deploy a Docker container and host it in Amazon Web Services on the Elastic Container Service, or ECS. And this is going to be a complete guide from scratch where we're going to be building a image locally in Docker, and then we're going to be pushing this image into the Elastic Container Registry, or ECR, which is another AWS service that lets us host these actual images. And then finally we're going to be deploying this using a task in our ECS, and that's going to let us actually at the end of the day be running our Docker container in an EC2 instance through the AWS environment. So a lot of steps here, but in this README I'm documenting everything that I'm doing so you guys can follow along, and I will provide all this code to you in a GitHub link. So we'll get started. And before I do anything else here, I'm just going to show this little Flask application running locally on my machine. So basically I'm just going to go here, I'm going to run app, and it's just going to start up a little web server here. So if I were to go on a new tab right here and view my local host, we're seeing that we're getting a nice little response here. I'm going to kill this web server right now and just confirm that we are still getting this thing. It's going to die now basically, but that is what our Python app does. And so the next step we're going to want to do is we're going to want to actually build a Docker image. And so to do that, I've already installed Docker locally on this machine. You'll have to do that if you're doing this on your own machine. And so we're going to make sure that we are in our project directory. I'm using PyCharm right now, so they've got this little terminal thing here. It's kind of cool. And so basically I can just paste in this command, docker image build -t. So it's going to tag the image, and it's going to be called Flask demo-vs space dot. That's going to tell it to build the actual image to the current directory. So I'm going to hit enter right here, and it's going to start looking through the requirements.txt file and the Docker file, and it's going to grab all that stuff. And just while this thing's going, something I want to make note of here is that you have to be very careful with your requirements.txt file in terms of the versions that you're using, because Docker and AWS can be kind of picky in terms of the dependencies that they're okay with. So making sure you find the exact versions of these things that work and that are compatible, that are actually available for Docker is very important. It's something that I spend a bit of time doing, and basically you'll get a bunch of build errors every time you try to build this if you're using something that they don't have a version for. So you just want to make sure of that, and then like test your application to make sure that it is good too. But this is a working set of versions for our dependencies. And so what we've just done is we've finished creating an actual Docker image locally. And so now what we're going to do is we're going to run this Docker image on my machine. And so we're just going to run this command right here, and we're going to paste this guy in just like that. You're going to see it comes back to me with a container ID. And so we've also bound port 5000 on the host, which is my local machine right now, to port 5000 on the actual Docker container itself too. So if we pull up another browser window right here and go back to localhost port 5000, we can see that our Docker container is successfully running this stuff as we expect it to. And so what we're going to do next though is we're going to copy this guy, and I'm going to run the command docker stop, paste in that container ID, and now we no longer have that container running, which is what we want. We're also going to free up resources here just on a local machine so that you don't be too wasteful with any of this stuff. And basically it's just getting us some extra space back on our disk if you're doing a lot of development, which I highly recommend you be diligent on. And then also we can see the images that are present on our local machine by running this command docker image ls. And so that is what we have here. It shows us all this stuff, which is great. And so now what we're going to do is we're going to get to the part where we actually are going to make use of the AWS command line tool, the CLI, for uploading this Docker image. And so if you don't have the AWS CLI already installed, you have to go to this link and go through that process. It'll depend on your operating system. I've already done this, but once you've done that, you're going to need to go to the AWS console. And in this AWS console, give me 1 second, we're going to sign right in. You're going to want to go to IAM. So we're going to open this guy up right here. And so basically what we're doing is we're going to make a specific user and attach rules to them so that they are able to access the Elastic Container Registry, the ECR service, as well as the Elastic Container Service itself, ECS. So what we're going to do is we're going to go into this IAM dashboard, and then I've already got a user to do this, but I'll make a new one just so we can walk through this process. We're going to click on Add Users. I'm going to give it a username, so you can call this like ECR and ECS full access. And you're going to choose credential type as access key. It's because we're going to be doing programmatic access through the AWS CLI. We're going to click on attach existing policies directly, and you're going to just search for these policies. Amazon EC2 Container Registry full access. If you expand it, it tells you what it does. So we want to have admin access to the ECR resources, which we will need because that's how we're going to be pushing our actual Docker images into AWS. So we're going to want that one. And then in addition to that, there's another one for ECS. And we just search that. You can get Amazon ECS full access. We're going to also be adding this guy. Hit next. You can give this thing a name. So you can just call this, you know, ECR and ECS access. And you're going to review it, and you're just going to confirm that you like what you see here. You want to follow the principle of least privilege, so only give it exactly what you need. If you want to be super specific, you could maybe, instead of full access, just have write-only access. You can only append stuff into your ECR if you're super scared about people deleting things with this user account, but we won't be doing that. We're going to then click Create. And now what we're going to do is we're going to be brought to this page right here. I'll try to zoom out. Sorry if this is small, but basically what we have is an access key ID right here. And we also have a secret access key that I'm not going to show you guys. But basically that secret access key is something like a long string of characters just like this. And so once you've done that, you will then open up a terminal, or if you're on Windows, we can open up a command shell, PowerShell just like this. And so basically what we're going to do is we're going to come in here, and by this point you should have already installed AWS. So if you run AWS, you know, you should see this response where it's telling you, you know, you have to give it some command. So we're going to type in Aws Configure. And so basically what this does is it's going to ask you to input that access key and that secret access key. And so this is where you would paste in that stuff. So I've already pasted this in. So I'm not going to change any of these values, but basically we're just going to walk through this process. Give me 1 second. So Aws Configure, paste in that guy, paste in your access key, put in a default region name. I recommend US East 1 because that, at least for the United States, is, even if you're on the West Coast, the default region for AWS. And then you can just leave everything else blank. And so default output format's none. So basically you need to configure your AWS CLI to have the permissions needed to interact with ECR and ECS. Otherwise this next step won't work. So basically you need to do these steps to make it forward. Now we're actually going to upload our Docker image from our local machine to AWS. And so this is the part that all this prep work has been for. So we know we've got a good Docker image, we've run it, we've tested it locally, we've made sure that we've got the appropriate IAM credentials for actually uploading it from our local machine to AWS. And now we can get to the part where we are going to be pushing this image to the Elastic Container Registry. And so basically the way we're going to do this is, again, we're going to be opening up that AWS console. So just give me 1 second on that. So AWS console, and we're going to just type in ECR, and they should pull up the Elastic Container Registry right here, which is great. And inside of this, we're going to create a repo. So we're going to click on Get Started. And then you can give this repo any name you want, but I highly recommend keeping it the name of your image that you've called it locally. So in my case, I'm calling it Flask Demo VS. So I'm just going to stay consistent with my name here. We're going to keep everything else as default. We're just going to click on Create Repo. And the next thing here that's really cool that I want to draw your attention to is when we open up this repo, we can click on this thing called View Push Commands. And right here is where AWS is telling you the exact commands to run from your shell or your terminal in order to push a actual Docker image into this repo that we've just created. So very, very cool. And so basically what we're going to do here is we're just going to copy these commands, and this makes life a lot easier. So basically I'm already in the terminal in my project directory where I have my project that I want to be turning into that Flask image. I'm sorry, the Docker image. So basically we're gonna start out by just running this first command. They literally tell you what it's doing. It's basically confirming that we have the appropriate IAM credentials to do this job. So we're gonna get this login succeeded thing, which is great. We're also going to be building this again, just to confirm that everything is good. We've already built it, so it should build pretty quickly. And then I'm going to copy this next command. So basically the next thing we're going to be doing is once this thing finishes building that image locally, we're going to run this next command to tag this image, just that has a name, so that we'll be able to reference it by name when we're pushing this into the ECR in AWS. So we're just going to copy this last command, paste this guy in here. We're going to then actually paste in this and run it. And so right now is a part where we are actually uploading our local Docker image into AWS. And so in the back end, they might be using something like an S3 bucket to just store this stuff. So I'm going to cut the movie right now. We'll wait for all these uploads to finish. Depending on the size, it can take quite a while, plus your internet speed. So we'll be back once this thing finishes. Alrighty, so we've just finished with the uploads now to ECR. And so we've just got this success message in our terminal from our project directory. So now that we've done that, if we close out this window in AWS, I'm going to make this full screen just so we can see what's going on here. We're going to go back to our repos, click on this repo, and you can now see that we've got this image artifact present. So they did some compression here, but basically we have successfully uploaded our Docker image into ECR successfully. And a very important thing to make note of here is that you're going to copy this URI. So this URI is basically how you're going to share this image with the Elastic Container Service that we're about to use in just a second. So make sure you copy this URI from this repo. And I'm going to minimize this window right here. And in my case, I'm going to just open up like a notepad just for myself to have this thing. We'll paste this in. I'll just say URI is equal to that. Okay, and we're just going to remember this for later. And now what we're going to do is we're going to actually go into the ECS service within AWS. So again, I'm going to go here. We're going to open up this guy, and we're going to then search for ECS. And this is the Elastic Container Service. So we're going to open up this just like that. Sorry about that. I'm sorry, this guy does not like running this in the half screen mode, so give me 1 second. But basically what we're going to be doing here is we're going to click on clusters, and we are going to want to create a new cluster. A cluster is basically a group of resources that we're going to be allocating for our Docker images or our containers once they're running. So we're going to want to go with EC2 Linux plus networking. So we're going to click on this guy, click on next. We're going to stick with on-demand instance. You can give this thing a name, so I'm going to call this the Flask cluster. You can call it whatever you'd like. In terms of the EC2 instance type, you are literally telling it what type of EC2 instances you want to go with. Because we want to stick with the free tier, you're going to go with t2.micro. This also changes how much available memory and compute resources you have. We're going to only go with one instance right now, and we're going to stick with the built-in Omni ID. So this is basically the operating system on that EC2 instance that we're spinning up. I'm not going to have an SSH key pair to this, although you could create one a priori and then select it from here, like I've got these other key pairs. But in my case, I'm not going to change that. They do have a minimum EBS volume of 30 gigs, so you have to stick with that. And then in terms of the networking part here, we're going to select the VPC that already exists for our AWS account. We're also going to choose the subnet that already exists within that VPC. And then also in terms of the auto-assigned public IP, we're going to make sure that this is enabled. And then finally, in terms of security group, leave this as the default. We're basically going to be spinning up a new security group alongside the EC2 instances that are getting provisioned for this cluster. And then in terms of the container instance IAM role, we're going to not change any of this stuff and just hit create. And so right now, basically what's happening is they're using CloudFormation in the backend to spin up the resources that are going to be needed for hosting our actual Docker containers. And so this part can take a few moments, so I'm going to give this a little bit of time and then we'll come back to it once it's done. While this is going, another thing we can look at is if we open up a new tab in AWS and we go to the EC2 dashboard, we will see a new instance here that should be coming up online. So this pending guy right here is the one that is being provisioned through this CloudFormation stack. So if we refresh this guy, we should see something coming online. So now what we're going to do is we're going to click on this Elastic Container Service Flask cluster. We're going to go here. Okay, so what we're going to do now that we've created it is we're going to go to back to the ECS page, so Elastic Container Service, and we now have this Flask cluster that is running right here. And so now what we want to do is we want to go to a task definition, because we want to define a task for our cluster to do. And in our case, I'm going to create a new task definition. So we're just going to ignore this guy right now. So we're going to go to Flask task, and I'm just going to hit deregister, so you can ignore that for now. We're going to be starting from scratch. So basically what we want to do is we want to go to task definitions, create a new task definition, and then we're going to choose EC2 because that's the type of resources that we're going to be working with here. I'm going to go to next step, and I'm going to call this the Flask task demo. And we are going to not change anything about the task rule, not change anything in the network mode. And then in terms of the task execution IAM role, we're good with that. In terms of task memory, you have to be careful here. If you put 1, you can run into errors. You have to specify also the units. So from this specific example, what I found works is 512 megs, and they really don't like me doing that for some reason. So just go with 512. So it's basically using up 512 megs of the 1024 megs that are available on the instance itself. And then also 1 vCPU is the unit that they want to see for the task. So basically you're telling how much of the resources on the host machine itself can be allocated to this Docker container that we'll be running. And now we're going to actually specify the specific container. You can call this whatever you want. I'm going to call this the Flask container. Try to spell it right. We're going to go to image, and this is the part where it is very important for us to remember the image URI that we copied from earlier. So I'm going to just copy that guy, paste it in right there. And in terms of the memory limits right here, you can leave it as default. And in terms of port mappings, this is where you have to be careful. So again, we're going to say that port 5000 on our host is going to be bound or mapped to port 5000 on our container itself. We're not going to do anything with this advanced section, and then we're just going to hit add. And so now that we've done all this stuff, we are done with our task. So we're going to create the task, and our task was just made, but that's not good enough. We need to actually run this task to actually take that container, specifically the image, and then deploy it onto our EC2 instance that has been spun up. So basically we got to go to task definitions again, and then we've got this Flask task demo here. So we're going to select this guy, choose actions, and then choose run task. And you're going to choose launch type as EC2 because that's where we're launching. And we are then going to keep all these other things as defaults, not change anything, click on run task. And now it's going to actually go through the process of running this task. And as this thing's running, you can hit refresh right here, and eventually you should see this green thing right here come up. That means that it has successfully taken that Docker image and turned it into a container running on that EC2 box that we have. So if we go back to here, we can now see that we've got this EC2 instance that's running. Ignore these guys, these are from earlier attempts. We're going to click on this instance ID, and now we've got this public IPv4 address. So we're going to copy this guy, and we're also going to recall the fact that we mapped port 5000 on this specific host to port 5000 on our Docker container, which is running that Flask web server. So basically if we go here, we paste in this guy, and then we try to hit port 5000, what we're going to get is a network timeout. And the reason for that is because we need to update our security group right here. So we're going to click on security tab, go to security groups, and we're going to click on edit inbound rules for the security group that's with our EC2 instance that's running our Docker container right now. I'm going to click on add rule, do custom TCP, and we modified, or we bound port 5000 on it. So we're basically going to allow any traffic from, this is IPv4 traffic, and we also want to do the same thing, allow any traffic from any IPv6 address. So that's just IPv6, and we're going to save these rules. And so now that we've updated our security group policy for the EC2 instance that's running our Docker container, if we go back to this guy, refresh this page, we can see that we are now getting our Flask container to work, and we're actually able to hit it from an outside world. So anyone can now reach your Flask web application. And now that you've done this, you've successfully deployed your Flask app and your Docker container to AWS, and we're all sticking on the free tier here. And so basically, once you've done all this stuff, how do you clean up to make sure you're not going to get charged for stuff after you're done playing around? The way you do that is we're going to go back to this ECS cluster right here, and we're going to click on the cluster name and click on delete cluster, and we're going to click on delete me, or just type that in. And this does take some time to complete. It's basically a CloudFormation stack, so there's a bunch of other resources like an auto-scaling group and other things that have been provisioned in the back end to make this all work. So basically it will take a few minutes for that to finish up. In addition to that, to make sure you're not going to get billed for like S3 or however they're hosting the repo for your code, you're going to go back to ECR, and then this repo where we've initially uploaded our Docker image to, we're going to click on it. We're just going to click delete, and again, type in delete right here. And now that we're good on there, we can also go to the EC2 dashboard. And here we're just going to make sure that we're terminating our instance. And as you can see, it's already been terminated by the process right here where we are deleting our cluster. So fortunately, they are good enough to make sure that we're deleting that component as well. But this is what you want to do to make sure that you're not going to get billed for, just random stuff down the road that you're not using. So that is going to wrap things up for this video. And if we refresh this, you'll see that our website is now dead because we no longer have an EC2 instance to host it. So we'll get a network timeout error. But that is how you clean everything up once you're done. I hope this is useful stuff. I'll post a link to the code and the README so you guys can follow along with all this stuff. Let me know if you have any questions. Thank you for watching, and be well.